This is a tutorial on properties of definite integrals. So let's just go through these. The first thing you need to think about when dealing with definite integrals is it's nothing more than just area under a curve. So if we have from A and we'll have B over here. So this first integral says find the area under the curve from A to A. So if we have from A to A, we have an infinitely thin rectangle. Sorry, we have a rectangle of area 0. We have a height of f of x, so the height here is whatever f of a is. And then with the width is 0, so f of a times 0 is 0. So that one's like this. If we have a situation in where a to b is equal to a constant. So the function is a constant. So we don't have this function anymore. I'll just move it up. But we have another function that is just a constant. So we can have something like this. Well, then that is a perfect rectangle, the one just like you're used to. And we have C, so this is C here. So the height is C, and the width is B minus A. So the area is B minus A times C. On the next one, we have the integral of C f of x. We can just take the integral of C times f of x, or we can just move the C out in front. So you take the integral of f of x and you multiply it by C. That one doesn't need too much of a picture. And then this one says the integral from a to b is the same as plus the integral from b to c is the same as the integral from a to c. So if we stick out a c here, we have the integral from a to b and then b to c. That of course is we just add the areas and we'll get the integral from a to c. It's the same thing. So we can split them up as well. And then if we have this f of x plus a constant, so we take f of x as this curve here, and then let's say we add 3 to it. So we shift the whole thing up 3. So here's f of x, and then we shift it up 3. 1, 2, 3, like this. The old area of f of x is right here. Used to be. So the old area is f of x right here, and then we shifted it up 3. So instead of just adding 3 to the area, well, we're actually adding a big rectangle, which is 3 times the width, which is the same as this piece over here. So as soon as you shift a function up, you're adding a rectangle underneath with area. And then this one, the last one here, the integral from a to b of f of x is the opposite, the negative, of b to a. So this is a little bit confusing because we're thinking about negative area now. And the way I like to think about it is this is a positive and this is a positive. So I'm adding a positive rectangle when I take the area of this rectangle here. But if I have a positive y value times, and I'm going in that direction from b to a, where b is bigger than a, then that's positive height and negative width. And you can say that that's the exact opposite, basically. That's negative. Okay, so those are your properties. So let's do an example. The area from 0 to 7. So we have an area from 0 to 5. So I'll just maneuver this over here, something like that, and finish this off. So from 0 to 5 is 10, and from 5 to 7 is 3. So it should look something like this. From 5 to 7 is 3. and that's 0. So from 0 to 7, should be 13. From 5 to 0 should be negative 10, so it's the opposite. From 5 to 5, that's no area there. And then 3 times f of x from 0 to 5, well, that's the same as 3. Bring the 3 out in front, 0 to 5 of f of x dx. And then this is 0 to 5 is 10. So this is 3 times 10, which is 30. And the next one, we have a function that has an area of 0 from negative 1 to 1. Well, there's only a few ways we can draw this. So let's say it's something like this. It's sort of like maybe like a sine curve. So this area is positive, and this area is negative. See, remember when I said a few minutes ago, this is negative height, and positive, we're going from negative 1 to 0, or negative 1 to 1. So that's positive width and negative height, which gives me negative area. Okay, so something like that. So this is negative 1, and this is 1. So from negative 1 to 0, well, if 0 to 1 is 5, and negative 1 to 1 is 0, then that must be negative 5. So this is negative 5. 0 to 1, which is 5, minus negative 1 to 0. So minus negative 5 is 10. This is 3 times the integral of negative 1 to 1 of f of x. Put it out in front. And then negative 1 to 1 is 0, so it's 3 times 0. 3 times 0, which is 0. And then 3 times f of x from 0 to 1. So 3 f of x 0 to 1 of dx is 3 times 0 to 1 is 5. So that's 15. And one more slide. So consider the function f that is continuous on the interval of negative 5 to 5. So we'll say that this is negative 5 and this is 5. The area from 0 to 5 is 4. So let's maybe make a picture like just like we had before, I guess. Something like that. So this is 4. Okay, so if I shift the whole graph up 2, so check this out. So if I shift this whole graph up 2, well, not that, shift the whole graph up 2, 1, 2, like this. I have this area, which is 4, and then I have a rectangle underneath. A rectangle underneath. So this rectangle has a height of 2 and a width of 5, so that's 10. So we should have 4 plus 10, which is 14. Okay, so then what we're talking about on this next one, 4 plus 10 is 14. So on the next one, it says the interval is now from negative 2, so negative 2 to 3. Negative 2 to 3. So this function, which was right there, is now moved, over here. Okay, and it's the exact same area. We're talking about area here. It looked like that, so now we have, it should still be 4. You notice that the interval is still 5 wide. It's all shifted to the to the left 2, and so did the intervals, so it's the same thing. All right, so now this next one is a little bit confusing if you don't know what what some of these terms mean. So an even function is symmetric about the y-axis. So we can draw it like this. So when I plug in 2, I get the same thing if I plugged in -2. That's what an even function is. Evens, I think it probably gets its name from like x squared. It sort of looks like x squared, or maybe x to the 4th. And when you plug in a positive and a negative, you get the same value. Okay, so if it's even, so it's perfectly symmetric on the y-axis here. So this is 4, and then that would, of course, would also be 4. So then this would be 8. If it's odd, odds come from like maybe the cubic function, which means it went like that. The exact same graph. When I plug in 2, I get the same y value but negative, or but opposite. So when I plug in 2 and I get maybe 8, I plug in -2 and I get -8. That's what that means. So if that's 4, then that one must be -4, which would be 0. And there's your tutorial on properties of definite integrals.